Now we're going to look at equations that use inverse trig functions in the equation. So if I want to solve for tangent of 3x for x, I can do tangent of 3x equals y over 4. Then to isolate the 3x, I would take the tangent inverse of both sides. And then I would divide both sides by 3. So this would be where x equals 1/3 arctangent of y over 4. This is an equation. I'm not solving for a numeric value for x. I'm just getting x by itself. So the key takeaway here is the way to get rid of the tangent in front of a 3x is not to divide by tangent. It's to take the inverse of both sides. That's the key here of this entire section. What about this one? Now I have 3 arctan of x equals pi. So I want to divide both sides by 3 first, and then I have arctangent of x equals pi over 3. I can't divide both sides by arctangent to get x alone. I have to take the tangent of both sides. So if I have tangent and I'm trying to get rid of tangent, I take the tangent inverse. If I have tangent inverse and I'm trying to get rid of it, I take the tangent of both sides. Now I know what the tangent of pi over 3 is. It's the square root of 3. So in some ways, these are a little bit easier. What if I have secant inverse of x equals cosecant inverse of 2? Well, first let's figure out what is the cosecant inverse of 2. Well, it's where cosecant equals 2. So I'm just going to call that u for right now, and I'm going to solve for it. So if I have secant inverse, I would take the secant of both sides, and then I'm going to plug that u back in. Notice I'm not necessarily asked to complete this question, but I know what cosecant inverse of 2 is. I can find that with my trig chart or by building a triangle. So that if I build the triangle and I know that cosecant of 2, well, cosecant is related to sine, so that I know sine is opposite over the hypotenuse and the reciprocal of 2 is 1/2. So opposite, hypotenuse, use the Pythagorean theorem. So that I know that secant is going to be the reciprocal of cosine, which is going to be my adjacent over my hypotenuse, but secant is the reciprocal of that, so it would be 2 over square root of 3, which we have to rationalize. Now what about this one? I have 2 x's involved, so I want to isolate one of the inverse trig functions. Once I get one of them isolated, I can take the sine of both sides to get rid of that sine inverse, and then I can follow that same process using the difference identity, because I'm going to say, well, u is going to be arc cosine of x, so I get u minus pi, which I'm going to expand out. Then I'm going to say, well, what is negative sine of u? I'm going to use the fact that cosine of pi is -1, sine of pi is 0. So when I do that, this entire second portion is gone. This is -1, so I have negative sine u. Then I'm going to take it and I'm going to look at, by definition, negative sine of u, which we define sine as arc cosine. So I'm going to be able to draw it out in my coordinate plane, find my triangle, find all the values, and sine of this is going to be the square root of 1 minus x squared. Now what about this one? I want to substitute sine of u into the equation, and then I'm going to solve for x. So this process can be quite a bit of algebra to get to a final answer. Then we're going to check our solutions. Well, is it true? When I plug in this, do I get an actual true value? No, I don't. So that means that's not a solution. So I'm going to check the next one, and I see that I have the range of arcsine is -pi to positive pi over 2, so that does work. So my solution set is going to just be this answer, not the other one.